Alright, welcome. My name is Mr. Shafter. This is going to be the very first of the flipped videos. This is going to be about reflection, and the topics are going to be on reflection in general and then the law of reflection. Alright, so we may as well get started. Reflection. When a wave reaches a boundary between two media, part or all of the wave bounces back. Then this is called reflection. The boundary can be between different types of media or the same medium but with different properties. Let's explore both of these. If I've got a wave-like phenomenon and it enters into a region of different properties, it can be a different type of materials. For example, light going from a vacuum into glass or hitting a boundary like metal. It can be it could be a sound wave, and it could be hitting a wall. It could be a sound wave and it could be in water and hitting an area of different density or different temperature or different salinity if it's in the ocean. Whenever we have a wave that hits another medium, the three things that can happen are it can go right through, it can bounce off, or it can be dissipated along the surface in something called a surface wave. We're not going to worry about going through, we're not going to worry about the surface wave, but we are going to look at what happens when things reflect. When things reflect, what you're looking at is the wave is energy. We've got a medium that is moving, or in the case of an electromagnetic wave, we have an oscillating electric and magnetic field, and this is stored energy. Whenever we have any interaction between other materials, there is going to be some energy exchange, and the energy can't be created, it can't be destroyed, it has to go somewhere. Part of it can go through, but part of it can be reflected off. It can be repelled, and when it's repelled, that's what we call reflection. Now, as I say, it doesn't have to be the same material. It can be different types of materials. A light hitting a mirror, it's going from air passing through glass, hitting the metal at the far end of the mirror, and then bouncing off. That's reflection, and the incoming light is going to bounce off of that metal and come back out again. And that's a special type of reflection that we call specular reflection that we'll talk about in a little bit. But this is reflection. Wave comes in, bounces off, goes in another direction. That's reflection. Now, as I said, it doesn't have to be different types of material. It could be the same type of material. In the ocean, there are things called thermoclines, which are areas where the temperature of the water changes rapidly. And these thermoclines are notorious for having different acoustic qualities than the surrounding water. So if you're at the top and you're looking for a submarine way down at the bottom, and there's a thermocline in between, you ping your sonar, your sound wave, that goes down, bounces off the thermocline, you're never going to see that submarine. And this is one of the things that nuclear submarines do in order to get away from people who are trying to detect them, is they dive underneath the thermocline, knowing that it will reflect off the sound energy. It'll bounce off just like a ball bouncing off a wall. Okay? The second part here, the law of reflection, right? A mathematical relationship between what comes in and what comes out. The incoming angle, measured from the normal, always equals the outgoing angle. And the angle of incidence equals the angle of reflection. This is true for any type of wave, whether transverse or longitudinal. We remember from mechanics that whenever we have a surface, that we can construct a line that's perpendicular to that surface at any point. Instead of saying the line perpendicular to the surface, we say the normal, because that means exactly the same thing. The normal is where we always measure reflection from, because the surface itself can be very, very complicated, and it may not be clear where exactly things are bouncing from. But if we construct a normal, and we measure the incoming angle, and we measure the outgoing angle, we find that they're going to be the same. That is the angle of incidence, the angle of the light coming in, and the angle of the light going out, or the sound coming in and the sound going out, or the radio wave going in and the radio wave going out. It doesn't matter. The incident angle, the incoming angle, will always equal the outgoing angle. Always, always, always. What are the exceptions? There are none. It's as simple as that. The incoming angle, which we represent by theta sub I, the incoming angle, that will equal theta sub R, the outgoing angle. And it will always be this case. It will never be any different. Ever. 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 And that's all there is. I mean, the law of reflection isn't that complicated. It's an equality. What comes in, measure that from the normal. And the critical thing is always measure it from the normal. Whatever that angle is, that's going to be your reflection angle. The critical thing is finding that normal. If you got a nice flat surface, it's going to be easy. If you got a complicated surface, it's going to be hard. But that measurement of that angle is going to determine what the angle of reflection is based upon the angle of incidence. Okay, that concludes the first of these videos. I mean, it's not going to be complicated. It's not going to be long. If you have any questions, ask me in class. You can email me. You can post it on the forum that I'm going to be creating for this. But that's all there is to it. We'll see you soon.